Hi guys, Ajay here, and this is a JAC capsule on factoring. Can we use the product sum method on polynomials that are not quadratic? So can I use the product sum method on non-quadratic polynomials? The answer is sometimes. So let's take a look at this x to the fourth minus 20x squared plus 100. There are a few things that I want us to notice about it. The first is that it's a trinomial, meaning that it has 3 terms. So that's similar to our quadratic polynomials, which we know are ax squared plus bx plus c. The second thing about it is the first term is x to the fourth, and that 4 is even. And then the last thing that we're going to notice here is that x squared is actually the square root of x to the fourth. So if I want to look at the square root of x to the fourth, that's like the square root of x squared times x squared, and it equals to x squared. So in other words, the x squared that shows up in my second term is the square root of the x to the fourth from my first term. Now, all 3 of these things together are the thing that allows me to use the product sum method on this. The reason is that now I can actually write this as x squared squared minus 20x squared plus 100, and think of factoring this into 2 quadratic polynomials instead of into 2 linear polynomials. So in other words, we're just treating that x squared as if it's the x. So we're looking for 2 numbers whose product is 100. So we want m times n is equal to 100. And then we want m plus n to equal to minus 20. Now, a couple things here. Our product is positive. So that means that either both numbers are positive or both numbers are negative. But because their sum is negative, that means both numbers must be negative. So these 2 things together, both numbers must be negative. So we're doing the same thing here. We're looking for those 2 numbers. If we're a little unsure what those 2 numbers are, we could be like -1 times -100 is equal to positive 100. -2 times -50 is equal to positive 100. Oh, but up here, -1 minus 100 is -101, which is definitely not -20. And here, -2 minus 50 is -52, which is definitely not -20. So then we'll move on to 3. 100 is not divisible by 3. So we'll move on to 4. -4 minus 25, that does equal to positive 100, but again, -4 minus 25 is equal to -29. So then we're going on to 5. 100 divided by 5 is 20. So this is -5 minus 20, which is, sorry, my bad. The product is 100. But the sum, the sum is -25. So we're still not at -20. So -5 minus 20 is -25. Then we would move on to 6, but 100 is not divisible by 6. In other words, if I try 100 divided by 6, I'm going to get a decimal, I'm going to get a remainder. I don't have 6 times some number equals to 100, times some integer equals to 100. It's also not divisible by 7. Turns out it's not divisible by 8. It's not divisible by 9, which brings us to 10. -10 times -10 is equal to 100, and -10 minus 10 is equal to -20. So maybe you saw that from the beginning and you got to skip all of this. Lucky you. If not, this gives you a nice, easy way to go through each of the numbers until you get to the one that actually works. So here we have the 2 numbers are -10 and -10. So that means that this is, instead of x minus 10, I'm going to have x squared minus 10. and x squared minus 10. And then I have factored this thing using the product sum method, but I didn't have a quadratic polynomial. I actually had a power of 4. Now it's a little bit harder to see, but we can also continue factoring this because these are both difference of squares. So this is x squared minus 10 squared. And because that's a difference of squares, that's x minus the square root of 10 times x plus the square root of 10. And they are both squared. And this is my final answer. Voila, that's all. Bye, guys.